Hello and welcome to podcast.init, the podcast about Python and the people who make it great. So now your modern data stack is set up. How is everyone going to find the data they need and understand it? Select Star is a data discovery platform that automatically analyzes and documents your data. For every table in Select Star, you can find out where the data originated, which dashboards are built on top of it, who's using it in the company, and how they're using it, all the way down to the SQL queries. Best of all, it's simple to set up, and easy for both engineering and operations teams to use. With Select Star's data catalog, a single source of truth for your data is built in minutes, even across thousands of datasets. Try it out for free and double the length of your free trial today at pythonpodcast.com/selectstar. You'll also get a swag package when you continue on a paid plan. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, and dedicated CPU and GPU instances. And now you can launch a managed MySQL, Postgres, or Mongo database cluster in minutes to keep your critical data safe with automated backups and failover. Go to pythonpodcast.com/Linode today to get a $100 credit to try out their new database service, and don't forget to thank them for the continued support of this show. Your host as usual is Tobias Macy, and today I'm interviewing Sam Willis about Tetra, a full-stack component framework for your Django applications. So Sam, can you start by introducing yourself?
Sam, I am a full-stack developer. I've been working with Django and Python for 15 years. Spent the last few months building a new component framework for Django called Tetra.
And do you remember how you first got introduced to Python?
I found it at the same time as finding Django. So it was probably about 2006, and I had kind of grown frustrated with PHP and ASP, which were the two things that I'd mostly used up till then. Was looking around for something new, and there seemed to be at the time big debate going on about the strengths of Python and Django or Ruby and Rails, and I picked up Django first, and it was my first introduction to Python. That was it, really. Worked well.
And in that decision-making process, did you end up actually trying out Ruby on Rails and trying to build anything with it? Or was it just you tried out Django and that's the one that stuck and you never looked back?
Exactly. Picked out Django first and thought, this works well. I don't need to try the other one. I'll just keep going. Yeah, and it's been a really good toolkit. It's been my go-to for anything for the last 15 years, really. It's kept me busy with all sorts of work and side projects. I'm somewhat unusual in that I'm, as well as a full-stack web developer, I spent a big chunk of my early career doing physical product design. So I've kind of jumped between the two, back and forth. I've been firmly on software for the last 10 years on web development. It's been a good tool to use. So back in 2006, when I first picked it up, I was working not web development, and I built a kind of as a side project in my evenings. I built a social media aggregator. It was called Flutterbox, and that was my first big project with Django. And I ran that for sort of on the side for a couple of years until it kind of just fell to the wayside. Carried on with the day job. About 10 years ago, I started a online business built on Django with my wife, and it did well, and we got to the point where we could both leave our day jobs to run it full time, and as I said, the rest is history. We've been running that for 10 years, and for the last year or so I've been doing sort of freelance development as well. So yeah.
Very cool. You mentioned that you built your own business and then you did a bunch of freelance work, and now you have started building a new open source framework. I'm wondering if you can just describe a bit about what it is that you're building with Tetra and some of the story behind how it came to be and why you decided that this was something that was worth spending your time and energy on.
So I had been spending quite a lot of time doing kind of front-end development with front-end frameworks like Vue, and I was growing frustrated with the disconnect between the front end and the back end. The fact that you have to constantly code APIs, REST APIs, or whatever you want to use to connect your front end to your back end. And it really slows down the sort of velocity at which you can work. It sort of forms a barrier. Every time you want to try something new, you've got to swap back to the other project to implement the bit that you need to bring extra state to the front. So I sort of started looking around to see what other people were doing, and I came across Laravel Livewire PHP ecosystem, and the guy behind Livewire built a project called Alpine.js, which is a front-end JavaScript toolkit for providing really quick and easy front-end interaction without having to set up a full node toolkit to have it run. And it looked really smart, especially coming from Vue.js. There's so many, it was very much inspired by Vue.js. It's got very much the same syntax in the way you have directives that you decorate your HTML elements with to indicate what you want to do. And it also uses the reactive core of Vue.js as well to provide its reactive state management. And so I was thinking how best to combine these two things together. And that's sort of where the thought process for Tetra came from. So I would describe Tetra as a full stack reactive component framework. It sort of provides the glue between the front end and back end. And the kind of two key features are it has this public shared state that it passes down to the browser for your components that forms the Alpine.js state in the browser. And it has a private state for each component that is serialized and encrypted and also sent down to the browser on each render, which allows the components to be resumed when you call any of the kind of public methods on the component. So that's very much inspired by things like Livewire. But the other thing I wanted to do was bring in some of the kind of concepts of single file components from Vue.js. I think it's a much better way of working, and I think it's one of the kind of great successes of front-end frameworks, of the encapsulation of your front-end JavaScript with the templates, with the style sheets all in one place. And I wanted to try and find a way of doing that with Python, with Django. And so that's where it kind of sort of started from, really. So started building it first started tinkering with the idea back in January, see how it could work, and built a couple of sort of side little test projects to see what could work. One of the kind of the first versions was much closer to Vue.js, with the way that Vue.js had these single file components which looked like a HTML file, where you've got a script tag with your JavaScript in it, a template tag with your template in it, and a style tag with your styles in it. So I started off trying to build something based around that, using Python's import hooks to have a custom file type that you could import your components. It was getting quite complicated. It felt like it needed a lot more to make it work, and it would need much more integration into people's editors to make it work. So for Vue.js, there's a massive VS Code plugin make that work. So I kind of went back to the drawing board, and it occurred to me that with Python multi-line strings and type annotations, you could build a system that allows you to do syntax highlighting of multi-line strings in a Python file. So that's one of the first things that I built for it, and it's a separate project for other things as well. So it's sort of two parts: Python Python package that you can call source types that lets you just do type annotations of different languages for your multi-line strings, and a VS Code plugin called Python inline source that looks for those type annotations in your Python files and sets the syntax highlighting of the multi-line strings. So built that, and then kind of got stuck into building Tetra and building it up from there. I sort of made a little bit of noise online saying, look what I've built. It's early days, but would love some feedback. And had good feedback, so going to keep building it.
Absolutely. And in terms of the overall kind of problem statement for it, it seems like it's basically building full stack web applications is harder than it needs to be. Here's a way to reduce the friction. Let's just put everything in one spot, and then you don't have to think about, building two different projects and then building the interface between them and trying to keep all of that in sync. And I'm wondering how you've approached that overall problem prior to using Tetra and some of the points of friction that are kind of inherent in that full stack application development cycle.
So the plan is to build something that allows you to simplify the process of building websites and web apps. I wanted to make it so that people didn't need to install Node.js, didn't need to set up a full stack of front-end tooling just to build a simple website, which seems to be the default now. It seems that everyone that's learning to build websites now are told to start with React, install JS, have to get their heads around Webpack and all sorts of other build tooling, which just makes it so much harder. So the plan is to sort of combine that all into Tetra. So in the near term, it's a component framework that has the glue between the front end and the back end. In the longer term, I want it to become a way of managing the full stack of JavaScript as well within a Python app. So if you want to introduce other JavaScript libraries, I want to provide tooling that enables you to do that without having to fall back to using Node.js. I want it to be a kind of a just works solution. I think that's the thing that I particularly like about Django and Vue.js as the two kind of things that I've used the most. They're opinionated frameworks. They have everything that you need built in. They make all the decisions for you. You don't have to go off looking for different ways of doing things or different libraries to install and make those decisions. So Tetra's aiming for that. It's aiming to be a opinionated framework. And two, there's another project called HTMX, and the creator of that's been talking about a term that he's just called locality of behavior. This is the concept. It's better to have the code related to, say, a button click actually on the button rather than some other files somewhere else. So the example he uses is with HTMX, rather than, say, with jQuery back in the day, setting in a JavaScript file somewhere your event listener for the click event on the button and it being completely disconnected. With HTMX, you set the click handler there in your HTML on the button element. I think that's one of the things I'm trying to do with Tetra. It's trying to bring everything close together. So although he's using the term locality of behavior, I think that's sort of saying stick things on top of each other, whereas I think there's still something to be said about some level of separation. So although with Tetra everything's in the same file, they're just next to each other. So I'm kind of calling it close proximity of related concerns, sort of indicating that you're putting your things that are related to each other next to each other, so you know they're there.
Yeah, it's definitely a trend that has been growing in how, in particular, front-end work has been evolving, where it used to be you had your JavaScript file that had some logic in it, you had your HTML file that was separate, that designed the structure that the JavaScript would latch into, and then separate to that, you would have your CSS file that needs to know about everything that the other two are doing to be able to work effectively. And each of those three things would typically kind of grow and evolve in its own way, not even always in line with each other. And so you would end up with these large and convoluted files that had lots of conflated logic that wasn't really constructed in a way that would actually compose well together to be able to scale kind of logically into larger applications.
I think it also results in code rot in that sort of old style, where because of that disconnect between the different aspects of a single sort of function, it's very easy to lose track of code that's no longer being used, whether it classic one is CSS. It's so easy for CSS files to become bloated with styles that you're just not using anymore. Whereas if your styles are defined on the component themselves, it means that you don't lose that connection. If you then stop using the component, you stop using those styles. I think it's one of the big reasons why Tailwind and other utility first style CSS frameworks have been so successful, because you're bringing the styles to the component rather than having them somewhere else completely. Now, I'm not completely convinced by the extent to which Tailwind goes with its class attributes, but I could see Tailwind working well with Tetra, in that you could use Tailwind classes to build up components, but then you can also apply some additional CSS in your style definition on the component. And one of the things that I'm hoping to add to Tetra soon is post CSS support. So the intention is to be able to have SAS or less as preprocessors on your styles within a Tetra component, in which case you'll be able to use the extend operator to be able to apply, say, Tailwind styles to a component within the CSS definition rather than on the component itself. That's one of the next jobs in the very long to-do list.
In terms of actually putting the different kind of logical elements that go with this particular piece of functionality, where you've got, in the case of Tetra, the Django view code and the JavaScript code that is going to manipulate the HTML content and the CSS that's going to be applied to it, I'm wondering what are some of the sort of design challenges that go into figuring out how to define the appropriate scope for those components and make sure that they will be composable into kind of larger objects and larger applications?
I think, well, firstly, on the sort of style and JavaScript side, I think it's anything that is directly on the component that only used by that component, it makes sense to define in the component file next as part of the component. But because I would say with JavaScript, because Tetra is using ESBuild to build the JavaScript package afterwards, you can import any JavaScript file into your component. So for reusable functionality, you can import it into each of the components in which you are using it. And then it's all built together into one package with ESBuild. On the CSS side, again, I think it's just the styles that are only on a component you'd want to define within the component. The plan is on that to copy what Vue.js is doing eventually, enable you to have scoped styles, which is a clever trick where it automatically places an attribute on every DOM node that's created by that template on that component, and scopes the styles for that component based on that attribute, so that your styles can't leak into other parts of your front end. It can't leak into other components. So there's a plan to do that. On the sort of structuring your components or where to break the functionality between different areas of functionality, I think if we take the to-do list example, classic app, each line of a to-do list wants to be a component, but you don't need to break that up into a component for an input box, a component for the delete button. The component is encapsulating the behavior of that line. So if you think of it from the perspective of your Django models from your database, each model probably wants to be a component, and each query set that you are displaying on a page probably wants to be a model. So that's probably the kind of the general rule of thumb that, yeah, model instances probably want their own component, and you might have 2 or 3 different components that display that model instance in different ways depending on where it is. It's encapsulating a single line of functionality or a single list of functionality in a reusable way.
And so, as far as the overall landscape of being able to develop full stack applications, you mentioned HTMX as one of the libraries that's very popular and trying to maybe kind of pull back on the reins a little bit of everything being a single page app with a full on JavaScript UI framework such as React or Vue. And I'm wondering what you see as some of the kind of broader landscape of how people are addressing these problems, in the absence of a framework such as Tetra, where you do still have this separation of, the JavaScript on one side and the application on the other. You mentioned the Livewire framework for Laravel. Wondering what you see as some of the other kind of sources of inspiration or kind of states of the art for addressing this problem of kind of the rampant complexity that has come in for, the general web application development cycle.
You said Laravel Livewire is a big inspiration for this. In the Rails world, there's Hotwire, which I think is fairly similar, although I've not spent much time looking at it. There is another project for Django called Django Unicorn that takes the Livewire concept and brings it to Django. But it's very true to the Livewire concept. It doesn't try to provide an answer to encapsulating your components, JavaScript and CSS, and it doesn't sort of provide an answer to doing more than just the glue between simple user interactions and re-rendering on the server. So one solution is to use Alpine with Django Unicorn, which would be very much like what people do in the Livewire ecosystem, where they would use Alpine with Livewire to bring that extra functionality to the front end. I've kind of gone the other route, and I've started from Alpine and then worked backwards and said, how can we build a back end for Alpine that really takes advantage of its strengths, rather than having it kind of layered on top as an afterthought. And so that's where kind of the fundamental idea came from for having the public attributes on Tetra component that become the data model for a Alpine component on the front end. And Unicorn, which is a brilliant project and is far further ahead than I am with Tetra. So if you want to use something now, then Unicorn is a great one to use.
Need to automate your Python code in the cloud? Want to avoid the hassle of setting up and maintaining infrastructure? Shipyard is the premier orchestration platform built to help you quickly launch, monitor, and share Python workflows in a matter of minutes with zero changes to your code. Shipyard provides powerful features like webhooks, error handling, monitoring, automatic containerization, syncing with GitHub, and more. Plus, it comes with over 70 open-source, low-code templates to help you quickly build solutions with the tools you already use. Go to pythonpodcast.com/shipyard today to get started automating with a free developer plan. So in terms of the actual implementation and how you have approached this problem with Tetra, I'm wondering if you can just talk through some of the design and architecture and implementation details of what you're building and how you're weaving this into the Django framework and integrating the Alpine library and just the overall thought process that went into how to construct this into something that was kind of internally cohesive and made sense for somebody who's building on top of it.
It's quite complicated. So components are kind of the center point of Tetra, and they all are rendered on the server using Django templates. But whenever a Tetra component is rendered and sent down to the client, it's actually serialized that state is saved. So One of the differences between Tetra and some of the other frameworks is that rather than confining the resumable state to objects that can be JSON serialized, with Tetra, I'm using Pickle, the built-in Python serialization tool. So almost any Python object can be saved as part of that state. Now, obviously, with Pickle, there are all sorts of security concerns, because if someone was able to modify that state and send it back to the server, you've potentially got a pretty bad exploit there. So the state is actually encrypted and signed using Fernet, which is an encryption standard using AES, and the key is derived from Django secret key and the user's session ID. And that ensures that the state can't be modified when it's sent back to the server for resuming that component on any public method calls. And I've done a bunch of work to kind of make that state efficient. So Django model instances are saved as just a reference to the database. Same with the query sets. So it turns out that in Pickle framework, there's a built-in system for being able to do this. It's called persistent ID, and it allows you to hook into Pickle and, for specific object types, be able to replace the reference, the Pickle reference, with your own reference to recall your object from wherever. I've done that with sort of database things, but I've also done it with template blocks. So when you're using a component on a page, you can nest them. You can have other components within them or other content. So in the kind of the front-end world, JavaScript front-end world, think of these, call these slots. Django, with Django templates, has blocks, which pretty much are the same thing. So Tetra components can take additional blocks. If we naively just serialized and pickled the component, you'd end up pickling a bunch of templates into that state, which bulks out the saved state massively. So Tetra tracks down where all the blocks that have been fed to a component were defined and keeps track of that, so that when the state's resumed, it rebuilds back to its initial state. As well as the kind of the private state, there's the public state, which I talked about before. That's serialized with JSON, but an extended version that also supports dates and sets. Anything that there is a corresponding standard JavaScript type in the browser to the type on the server will automatically match. Tetra has these public methods that are made available to the Alpine.js JavaScript code on the front end. And when you call a public method from the front end, it picks up the state of your component, posts it back to the server. It's unpickled, and any parameters you've passed to that public method are then called on that method on the component on the server. It can then re-render the template with the updated state, any updated data from other sources, and that is sent back to the browser, and the DOM is morphed to the new representation from the server. So it uses Alpine.js's morph plugin to do this. So it effectively takes the new HTML that's been sent, temporarily makes DOM objects out of it, compares that to the DOM that's mounted on the page, and morphs the DOM mounted on the page to match the state the DOM that's been sent from the server. And this allows that. So, for example, if you are in the middle of typing in a text box, it doesn't just dump the text box out the way and bring it back, and you don't lose your cursor position inside the text box. So any local state is maintained. The other thing that you can do from public methods is a callback queue that allows you to call front-end JavaScript methods that you've defined as part of your component from the server. So if, for example, you have a to-do list and you, having modified an item in your to-do list, you want it to resort the to-do list, you can call a front-end method that fires an event that can then travel up to your parent component, which can say, I need to resort this because we've changed the text of this to-do list item and it needs to be resorted into alphabetical or priority list or something. Each component in Tetra is part of a component library, and all of the JavaScript and CSS for each component within the library are bundled together into a single JavaScript and CSS files. And this is done with ESBuild, which is a brilliant project. It's for building JavaScript and CSS. It's 10 times faster, literally, than Webpack and some of the other JavaScript build tools. It's written in Go. And so, although not quite yet, the intention is to bundle it with Tetra. So if you read the docs right now, it'll tell you need to install Node.js and install ESBuild using Node.js. That's definitely not the plan going forwards. The plan is to bundle ESBuild with Tetra so that it just works and you don't need to think about that front-end Node.js tooling. When the JS and CSS is built, also creates source maps for those files. So when you are developing your website using Tetra, if you have any JavaScript errors or you're trying to track down where the CSS property on an element was defined, the source map files will enable your dev tools in the browser to show you exactly where in the original Python file those things were defined. So that makes the development process easier and helps to mitigate some of the concerns I think people would probably have about putting JavaScript and CSS in their Python files. It brings that visibility to the front-end dev tools in the browser.
As you're talking about, having the JavaScript and the CSS in with the Python files, one of the things that comes to mind is that this is definitely very conducive to a full stack engineer's workflow, but I'm wondering what your thoughts are on the kind of approachability of this framework for when you have somebody who is more front-end oriented but wants to work on a project that's built using Tetra, and just some of the ways that you think about being able to accommodate people who have maybe more expertise in one direction or the other of front end versus back end, but want to be able to collaborate in a kind of full stack approach.
I think the advantage here is that Django is such a good framework and the documentation with Django is so strong that someone that has never touched the back end, has only ever done front end development, very first thing we say when you come to Tetra is, if you've not done any Django, go do the Django tutorial. The Django documentation, the Django tutorial is some of the best tutorials that you can get for any of these frameworks, I think. I'm confident that anyone that's battled through and got the hang of using React and Webpack and all of the other front-end tooling that you need, coming to Tetra and coming to Django maybe for the first time, I think they'll find it a breath of fresh air. I think they'll find their productivity increase and they'll pick it up pretty quickly.
And so in terms of the overall kind of design approach of how you thought about what are the pieces that I want to pull in. You mentioned they used Alpine.js. You mentioned HTMX as an alternative. I'm wondering what were the kind of deciding factors that made you go with Alpine.js and how you thought about the level of integration that you wanted to build into Django of, how much you wanted to actually get into the guts of the framework and how much to just keep it kind of componentized and just a layer that gets added on top of what Django already provides.
Choosing Alpine over HTMX. HTMX and Alpine are talked together basically anytime you see them mentioned online, and they can work really well together, but they're filling two fairly separate roles. HTMX, from my understanding, is very much geared towards calling server-side functions which return HTML fragments to patch into your page, I could very well have built Tetra on top of HTMX, but it doesn't have an answer to the kind of front end only interaction that Alpine has. So you don't have to call back to do a change on the front end with Alpine.js. You can just do the change on the front end. It gives you more strength on the front end than just HTMX. In an alternative stack, HTMX and Alpine.js, I think, work very well together. Tetra is kind of filling the role of HTMX for Alpine.js with Django. It kind of acts as that glue in the middle. So far, with what's been built, it's just a component framework, although I have had to go quite deep into the templating system to make it work. But the plan is to eventually be able to take over more of your Django app. So I want to enable a more SPA type app to be built with Tetra by having client-side routing between components. So the plan is to reuse the Django URLs, but make it available on the front end as well, so that you can construct a website just out of Tetra components that can either be rendered entirely on the back end on first view, but only the subcomponents would then be rendered and patched as you navigated through the rest of the site. The plan is to reuse as much of Django's own tooling as I can. Two reasons, really: to keep it simple, but also to make it easier for developers coming to Tetra to know what to do. If they've got 10 years experience with Django, I want to make it easy to transition to Tetra as possible.
As far as the syntax element, you mentioned that you have support for being able to provide highlighting of the different languages embedded in the Python files. I find it interesting that that was one of the first things that you tackled, and I find it very encouraging because that definitely speaks to a concern for the overall developer experience and the ergonomics around it, because having worked in many different contexts where you have multiple different languages or syntaxes jammed into one file, it's perennially frustrating trying to figure out which is which. And I'm wondering if you can talk to just some of the challenges or complexities that go into being able to provide that level of support, and how you think about maybe being able to support that across different editing environments so that you're not necessarily tied or locked to a given editor to be able to get that level of support.
You're quite right. I started there because my entire kind of motivation is developer user experience. I want to build something that is optimized for developer happiness, and convincing anyone to put HTML in their Python file in a significant way, or JavaScript even in their Python file, you've got to work quite hard to make that a convincing argument. It's only the first stage of what I want to do there as well. So I've only done VS Code so far. It's the editor I use. I don't use any other editors. I'm kind of hoping that someone else kind of picks up the mantle and goes, this is a good idea, and says, I'll contribute support for another editor, really. It's partly also why I built it as a separate project, because I could see the potential use of it outside of Tetra. The other day I was looking at Rich, which is a brilliant Python toolkit for doing really clever UIs, but within the terminal. So it gives you all the usual UI widgets that you would get in a normal desktop toolkit, but it uses the terminal to render it all. And the rendering and layout is all defined using CSS. And so you are writing CSS in a Python file with Rich to lay out your components, and using source types and my Python inline source VS Code extension, you'd be able to get syntax highlighting for your CSS in your Rich components. And they don't need to even add specific support for that to the library, it's just a type annotation, which is actually just an alias of string. So it can just be put in on anything. The long term, the thing I really want to tackle is IntelliSense or autocomplete. At the moment, we get syntax highlighting for the inline source, but no autocomplete. And that's going to require a significant amount of work. That's a few months ago that I was last looking at this. The APIs available in VS Code to do it aren't quite there. So jumping back to what we were talking about at the beginning with Vue.js and their single file components, their VS Code plugin is enormous. They've basically had to completely re-implement, I think, the HTML renderer, and VS Code has something called a language server to provide the autocomplete and other sort of language features. And that's a big project on its own, just the Vue.js VS Code extension. So again, my hope is that if the inline source highlighting project is successful on its own, then we can expand that and add those sort of features later on. And hopefully in an extendable way, because what I would really like to do with Tetra for developer user experience is to provide cross-language autocomplete. So when you are writing in a server-side public method, you can write self.client. And it will autocomplete with your front-end JavaScript public methods so that you don't need to sort of track of what's there. It just does it for you. And then the other way, I'd quite like it when you were coding in your JavaScript part of the component, if you got autocomplete for your Python server-side public methods. I think that's a very big wish. Little way off yet. Need to build the rest of Tetra and get people using it first.
As to that kind of longer term goals that you have for the project, I'm wondering if you can go over some of the maybe sort of grand vision that you have for it, where you would like to take it going forward, some of the potential roadblocks you see along that way, and how you are considering the overall sustainability and longevity of the project.
The problem I think that all large-ish toolkits sort of come up against when they start off, to become sustainable, they need to be used and grow a community around it that helps contribute back and helps maintain it and support it. But in order for people to commit to spending time in that community, contributing to a toolkit, they need to some extent believe it's sustainable and going to be around for the long term. So it's kind of that initial stumbling block now, which Tetra needs to get over. It needs to get to that initial little step where there's enough people interested in it that are going to push it forward and keep it running. I'm 100% committed to it. I think it's, well, obviously biased, but I think it's the best solution for Django going forward. And I want it to be the de facto first choice full stack framework for Django. I want people to be deciding to build with Django because of Tetra. And so I'm planning to spend my free time working on it and getting it to that point. As I said earlier, the plan's to get to a stable V1 release this summer, so that at which point I would very happily tell people to build launch production systems on it. And yeah, long term for me personally, I would love it to become an important part of my own kind of day job. I would, as a freelance developer, I'd love to get to the point where I was being paid to work on projects that were using Tetra or even on Tetra itself. But I think it's got legs. I hope other people do too. It's early days, but we'll see where it lands.
As far as the current state of the project, I don't know how much usage you've seen around it. You mentioned that it has gained some attention. I'm wondering, what are some of the most interesting or innovative or unexpected ways that you've seen it used? Or conversely, some of the interesting discoveries that you've made along the way of kind of maybe accidental benefits of what you're building and how you're able to use it?
I would love to be able to answer that question. Ask me in about 2 months. I think that's probably when I'll have a better answer for that one. I haven't seen much yet of what people have built. It's only a month out of the door, and it's going to take another month or so before I think I really see any projects launching that may have used it. Maybe I should come back in a month's time and tell you the answer to that question.
In terms of the experience that you've had building it so far, I'm wondering what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
The most challenging problem to solve was tackling the Django template system. It is complicated. It is very clever, but very complicated. And said earlier, one of the things I needed to tackle was a way of tracking template blocks. And I had to go fairly deep into the template system to work out how to do that. And in fact, I've had to patch Django's template system slightly to enable that, but it's an important part of Tetra to be able to do that. So yeah, most challenging thing was getting my head around the templating system.
So for people who are interested in the idea of being able to have a tightly integrated way to work with their Django applications and the front end interaction, what are the cases where Tetra is the wrong choice and maybe they're better suited with, using something like Livewire or just using HTMX or some of the other options for solving some of that problem of managing the complexity across the front and back end?
I think if you are building something that's in production right now, I think then something like HTMX is probably the right choice if you are trying to apply just a small amount of interactivity. My hope is that in 2 months' time, the answer will be don't use HTMX, use Tetra. I think also Tetra is probably the wrong choice if you are trying to build something that's sort of desktop class, trying to be a full-on single-page app with maybe even offline support. Tetra is not going to support that level of functionality. And that's where sort of the front-end tooling that's around now with Vue and React is the right choice. So I'd never push people to use Tetra if there are better options, because there's a lot of options out there. This is just another one.
And you mentioned a little bit about what you have planned going forward. I'm wondering if there are just any other elements of what you have on the docket for the near to medium term or any areas of contribution or feedback that you're particularly looking for.
So in the near term, there's a few sort of built-in components I want to make. The plan's to have a model component that ties in nicely with the Django ORM, so kind of bootstraps standard interactions for a component, so gets rid of even more code that you would have to write. So the to-do app example that's on the Tetra homepage, the to-do item component there, rather than write it the way it is, you would write it with a model component and probably end up with only about a quarter of the number of lines for that component that you currently have. So there's various components like that. I want to tie in with the Django form framework to bring forms and validation from Django to Tetra. Longer term, I want to bring some sort of WebSockets and server-side events maybe to Tetra. I want to be able to enable people to do real-time updates based on server state change elsewhere. So if a model changes in the database because another user has updated it, I want to provide a solution to update a separate user's session so that they can see that update happen in real time. And I've got a few ideas of how to do that. I'm hoping to have maybe a draft of that for V1 this summer. We'll see how that goes.
One of the things that I didn't ask yet that I just realized is curious where the name came from and what your process was for figuring out what to name the framework.
It's called Tetra for tetrahedron. The idea being that a Tetra component has 4 faces. It's got its server-side Python, it's got its front-end JavaScript, it's got its HTML template, and its style sheets and CSS. So you've got an object with 4 sides, and an object with 4 sides is a tetrahedron, hence Tetra.
Makes sense.
Yeah, that's the gist.
Are there any other aspects of the Tetra project or the problems that you're solving with it or your overall vision for it that we didn't discuss yet that you'd like to cover before we close out the show?
One thing I want, and I would love your readers to do, is go and have a play. Give it a go. And I want feedback. I want people to try building things and tell me what didn't work or what they need. One of the kind of mentalities I've got going into this is, to some extent, keep it small, keep the API small, not too big, and only add things when people ask for them. It's very easy to get carried away thinking about all the possible ways that people might want to use it and build everything possible. But you end up with something that's unmaintainable and too big. So the plan is keep it small, build when people ask for things. And so, yeah, go build stuff and let me know how you get on.
Yeah, keeping the Yagni principle in mind is always hard. You ain't going to need it.
Yeah.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to do some shameless self-promotion and announce the machine learning podcast that I'm launching. So for anybody who is interested in that area of engineering and endeavor, definitely recommend taking a look at that. It's kind of a natural outgrowth of the data engineering podcast that I've been running for the past few years. So definitely excited to bring that into the world. I just primed the feed and I'll be having episodes going live any day now and should be a roughly weekly release cadence for that. And so with that, I'll pass it to you, Sam. Do you have any picks this week?
My pick this week is Slow Horses on Apple TV. It is a brilliant TV show based on a series of spy novels, and it's starring Gary Oldman and Kristen Scott Thomas. It's well worth a watch. It's based on the idea of a bunch of disgraced MI5 operatives who get sent off to Slough House. And for the non-British listeners, Slough is a rather run-down and not particularly well-liked area of London. So the implication being that they've been sent out to do not real work and they get caught in a situation. And yeah, it's a good watch. Very good TV.
All right, I'll have to take a look at that. So thank you very much for that recommendation and for taking the time today to join me and share the work that you've been doing on Tetra. It's definitely a very interesting project, definitely excited to see it progress and potentially thinking about using that to build an application that I've got in mind. So I appreciate all of the time and energy that you've put into making that a reality and continuing to support it. And I hope you enjoy the rest of your day.
Thank you very much.
Thank you for listening. Don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest on modern data management, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you learned something or tried out a project from the show, then tell us about it. Email hosts@pythonpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.